So you will put this slash and then full stop for the substitution. And then what substitutions are going to make? We are going to make two substitutions. So if there are two substitutions, we can enclose it in the curly bracket in the form of the sets, or in the form of the set. So first substitution is u is equal to y over x. So you can just copy and paste it over from here. And the second substitution is dy is equal to u dx plus dux. And then close the bracket, curly bracket. Okay, so this substitution will hopefully be applied. And let's execute this command. So we get something like this. Okay, so maybe we need to simplify it. Okay, so you can take this command and then simplify it. Simplify, Control V. Here. Okay, and then there is not much difference when simplification. So our target is to make this equation as separable. So in this case, for making it separable, I put du on the left side, dx on the other side. So for this, what I can do is some of the terms are with du, some of the terms are with dx. So I can take these terms of dx on the left hand side, and this term also includes dx. So this term is dx, and then dx is also being multiplied by this. Here one thing is that in the in this equation now there should not be any y term, but we still are we still can see there are y terms. So it means that the things have not been applied very well, and I think I know what mistake I have done. I have made the mistake over here. I should not put u to y over x, because I think Mathematica does not know that by putting this it should be y to u over x. So I think I should put like y to u times x. Okay, so yeah, mistakes. One can make mistake, but it's good that we can correct the mistake as well. Okay, so I think by this mistake, I think the things will be relatively simple now. Okay, so now I got this. So now in this case, we can see that there are no y terms over here, but we still need to simplify it. Okay, so let me take this from here and copy it here. Okay, so now I enter it. So I get these values. Okay, so dx into ux into x, and you can see I can see that x is common in each term. So I can divide by, I can remove this, eliminate this x by division from both sides. So I can divide by x from both sides. Take a bracket here and then take a bracket here, and on the right hand side it will be so here I can see that it did not simplify it, so I need to also simplify it as well. So simplify. Okay, yeah, so yeah, so now the x has been eliminated, and then now what I can see is that dx I need to take on the other side. So what in the next step I can take dx on the other side. So minus this term minus dx u minus dx u. Okay, so it will be one of the dx term is here, but still there are some other terms of dx over here. So I can find the dx term and their coefficients over here, and then subtract it from the from this side. Okay, so for this I can use the find what is the dx term. So for example, coefficient of I can want to find from this expression the coefficient, and control V, close. But what coefficient I want to find? I want to find the coefficient of dx. Okay, and this is this value. Okay, this is this. It means that I can subtract this from both sides times dx. Okay, so I can take this equation. Okay, sorry. I can take this equation and then write it here, and then I can subtract this coefficient, which is the coefficient of dx. Control V, I enclose it in the bracket, and then times dx. Okay, and then the same on the other side. And probably when we will need to simplify as well. So simplify, and then up to here, and also simplify here. Simplify and bracket close. So execute it. So I get this. So now what I can see is dux, and there is still this but I think if once these terms are simplified, somehow Mathematica is not recognizing this value. So for example, log x is cancelling with this. Okay, so if Mathematica does not do it manually, automatically, so we can do it manually. Okay, so what we can do is over here, I can, because here it will be log x minus log minus log u minus log x. So log x minus log x will cancel. Okay, so what I can do is I can subtract log x. That will be minus log u, and then I will cancel out x from here. It will be 1 minus log u. So similarly from here it will be this will be minus log x, and then log x plus log x. So it will be left over here will be log u. Yeah, so it will be log u will be left out. Okay, so now we have this. So here we have this x, here we have this u, and here we have log u. So we still need to do some manipulations. Okay, so this bracket is extra, but it's fine. Oh, my Mathematica is not responding, but let's wait. Okay, so to make it separable, then what we have to do is now I have to subtract, divide. No, this will remain here. I will divide this by x, this side by x, and similarly this side by x, and then I will divide this side by log of u also. So I can put it like this, times log of u, bracket close. So same on the left hand side. Okay, so with this I think x is removed here from here, and then log u is removed from here, and then oh, there is u as well. So I have to divide by u. So u goes here, and then u times here. So I think with this, I think everything will be separated out. So now we get this. Okay, du into -1 over log u, or u log u over dx over dx. Okay, so now we can remove this du and dx from both sides. So because we want to now integrate, so you can remove it here. You can manually remove it here and then replace it with 1. And now integrate it with respect to u, and then integrate with respect to x. So it will be this, minus log u into minus log of u is equal to log of x. Okay, so it means that now we got this, and then the next step is to add constant of integration plus c. So in fact, this is the answer in the implicit form. Oh, rather it is not the answer, because we still need to replace u with y over x. Okay, so in the next step then I will put the replace parameter over here, and then I will replace u with y over x. So u with y over x. So it will be this. So this will be the answer, implicit solution. So actually we can see that it can be further simplified. So let's see whether Mathematica can simplify further or not. Simplify yeah, so Mathematica has suggested this kind of simplification. So c log x and log y over x. So I think the Mathematica did not simplify this, because log x and log y minus log x, so this will be cancelled out. So we can do this simplification manually. Okay, so we can take this c on the other side or keep it over here. So this log x will be cancelled, and then only thing which will remain will be the y over here. And then if you take, we can even further simplify it as well in terms of y. So the final answer will be y log